Example 4. Factor, if possible, the following polynomials by removing the GCF. 9h minus 18. Step 1 is to find the GCF of all the terms of the polynomial. If the GCF is 1, then you do not need to proceed to the next step. So what we need to do is look at the coefficients, 9 and negative 18. So we find the prime factorization of 9, which is 3 times 3, and the prime factorization of 18, which is 2 times 9, and then 3 times 3. So now when finding the GCF, we look at the factor 2. 2 occurs one time in this factorization and 0 times in this factorization. So 2 is not included. We look at the next factor 3. 3 occurs 2 times in the factorization of 9 and 2 times in the factorization of 18 as well. So we use 2 factors of 3. So the GCF of our coefficients is 9. Since only the first term has a variable, we do not include that. So now we move to step 2. Place the GCF in front of the parentheses. So we write our GCF, which is 9, and we divide it out of each term. So we have 9h divided by 9, which is h, and then negative 18 divided by 9 is negative 2. So in its factored form, 9h minus 18 becomes 9 times the quantity h minus 2. B. 15x plus 14y. Again, we find the factorization of our coefficients, 15 and 14. So 15 can be broken down to 3 times 5. And 14 can be broken down into 2 times 7. So we look at our factor 2. 2 occurs one time in the factorization of 14 and 0 times in the factorization of 15. So 2 is not included. We can look at the factor 3. 3 is included one time in the factorization of 15 and 0 times in the factorization of 14. So 3 is not included. 5 occurs one time in the factorization of 15 and 0 times in the factorization of 14. So 5 is not included, and you can see that 7 is included one time in the factorization of 14 and 0 times in the factorization of 15. Since we have no common factors, the GCF is 1, which means 15x plus 14y is prime, which means it cannot be factored any further. C, we have 3x to the 4th minus 15x to the 7th plus 24x to the 9th. So we find the factorization of each of our coefficients. 3 is already a prime number, so we don't have to go any further with that. 15 can be broken down into 3 times 5. And 24 can be broken down into 2 times 12, then 2 times 6, and then 2 times 3. So now we're going to find our GCF. So since 3 is a prime factor, and there's one factor of 3 here, there's one factor of 3 in the factorization of 15, and there's one factor of 3 in the factorization of 24, 3 is included as part of our GCF. Now 5 occurs one time here, but 0 times for 3, so 5's not included, nor can the 2's be included. So our GCF for our coefficients is 3. Now when we look, we notice that x is contained as a factor in each of our terms. So when choosing a variable, we choose the one with the smallest exponent, which in this case is x to the 4th. So for the polynomial, our GCF is 3x to the 4th power. So we put that in front of our parentheses and divide it out of each term. So we have 3x to the 4th divided by 3x to the 4th, which is 1. Then negative 15 divided by 3 is negative 5. We had 7 factors of x, and we removed 4 factors of x, so that would leave us with 3 factors of x, or x to the 3rd power. And then we have positive 24 divided by 3, which is positive 8. We had 9 factors of x. We removed 4 factors of x, so that would leave us 5 factors of x. So 3x to the 4th minus 15x to the 7th plus 24x to the 9th could be factored to 3x to the 4th times the quantity 1 minus 5x to the 3rd plus 8x to the 5th.